This is the video for section 11.1, Parts of a Circle. Please follow along with your video worksheet. The first section has all of the terms, definitions, and diagrams that I will be using, and the second section has all of the example problems that I will be showing you. Please fill in the worksheet as you watch the video. Let's begin. Now we begin here with a review of the Pythagorean theorem. A squared plus b squared equals c squared. Now we use this only for right triangles, and it's very important which letter goes on which side of the triangle. Now I always start with the C. The C goes on what we call the hypotenuse, and that's the side of the right triangle that does not touch the right angle. It is the longest side of the right triangle. Now the other two sides are called legs. They are A and B. Now it doesn't matter at all which one is A and which one is B. So I'm just going to write them on those two sides. What does matter is that C is always on the hypotenuse. Now using that triangle, we are going to solve for the missing side of each right triangle in the three examples I have here. So in example 1, the X is in the C spot. So I'm going to start right away by putting the X squared on the right side of the equal sign. Then the 12 and the 5 go in the A and the B spot in either order. So I go 12 squared plus 5 squared over here. Then I'm going to solve. 12 squared is 144 and 5 squared is 25 equals x squared. Then I combine my like terms. 144 plus 25 is 169 equals x squared. And then I take the square root of both sides to solve. And the square root of x squared is just x, and the square root of 169 is 13. So I finish with x equals 13. In the second example, my x is no longer on the hypotenuse, it's on one of the legs. So I'm going to start by putting it in the A spot. Now it could just as well go in the B spot, but just not on the C, which is the hypotenuse. So x squared plus the other leg is 7, so 7 squared equals the hypotenuse 25 squared. Now I start here by simplifying the 7 squared and the 25 squared. So 7 squared is 49 and 25 squared is 625. Now I solve this problem by subtracting 49 from both sides, giving me x squared equals 576, and then taking the square root of both sides, I get x equals 24. Going on to the third example, my x in this problem is also not on the hypotenuse, so it could be on the A or the B. So I'm going to put it in the B this time. 80 is my other leg, so I put that in the A spot. 80 squared plus x squared equals my hypotenuse 170 squared. Simplifying, I get 6,400 plus x squared equals 28,900. Then subtracting 6,400 from both sides, I get x squared equals 22,500. And taking the square root of both sides, I get x equals 150. Now we're going to be using these Pythagorean theorem skills as we go through this chapter. Now this begins our definitions, or parts of a circle. The first part of a circle is called a chord. A chord is a segment whose endpoints are on the circle. So here's an example of a chord. I have 2 points, A and B, that are on my circle, and then I connect them with a segment, AB. So remember here, a chord is a segment. So in this problem, segment AB is my chord of my circle because it connects 2 points that are on a circle. My second definition here is a diameter, and diameter is a type of chord, so we know it will connect 2 points that are on a circle. Technically, a diameter is a chord that passes through the center of a circle. So let's say here my center here of my circle is O, and then I'm going to draw a segment that goes through O and whose endpoints are on circle O. We'll call those endpoints X and Y. Now, we refer to this diameter as segment XY. Now, it's real important here to remember that we only use 2 letters for a segment. A lot of people like to write this as segment XOY. Now, that is definitely not a way to do this because we never write segments with 3 letters. My next part of our circle is called a radius. Now, radius is not a chord, it's just going to be a segment whose endpoints are the center of a circle and a point on the circle. So I'm going to start with my center of my circle, we'll call that O again. And then I have a point that's on my circle, let's call that C. And I connect the center to the point on that circle, and that's called a radius. So in this case, my radius is segment OC. Now moving on, we have 2 more parts of a circle that are not segments anymore. These 2 are going to be lines. First one is called a secant line. And secant line is a line that intersects a circle in exactly 2 points. So here's an example of a secant line. It's basically going to be a line that stabs through the circle in 2 points. We'll call that first point S and the second point T. So we write our secant line ST. The last one is called a tangent line, and a tangent line is a line that intersects a circle in exactly 1 point. So here's an example of what a tangent line looks like. It just barely grazes along the circle, along the outside. And that point where it touches is called the point of tangency, which is F in this case. And I'll put another point on my line, G. So my tangent line is FG, line FG, and the point of tangency is where that tangent line touches the circle, which is F. Question 4. Now, given this picture, we're going to identify each as a secant, tangent, radius, diameter, or chord of circle A. Part A says segment AB. Now, segment AB is going from the center of a circle to a point on the circle. And whenever that happens, we call that segment a radius. The second one is going to be segment BD. Now in this case, we are connecting 2 points that are on the circle, B and D. So this is a type of chord, but we notice that it also goes through the center of the circle, which is A. So whenever this happens, that chord is now called a diameter. Part C says line BC. Now because this is a line, it is not only inside but also outside the circle. So that green line that you see is line BC. It goes through the circle in exactly 2 points, so we call this a secant line. Next is segment CD. Now segment CD does connect 2 points that are on the circle, but it doesn't go outside the circle in any way. So it's very similar to the secant line, but it's not a line, it's a segment whose endpoints are on the circle. So we call segment CD a chord. And E says line EB. Okay, line EB. is the line that is outside the circle that barely just touches the outside of circle A at point B. Whenever we have something like this, we call it a tangent line. Moving on to question 5. This one's a little more complicated, but don't get overwhelmed. We are just going to identify the same exact things. So we are going to start with chords. Now remember, chords connect 2 points that are on the circle. So one by one I will highlight them and name them for you. First of all, segment PQ does have endpoints that are on the circle, and it is a segment, so it is a chord. Next, I have segment LQ. Segment LR. Segment RS. Now, we also have 2 more chords, and these are the ones that people sometimes miss. The first one is segment LN. People sometimes miss this one because they think it's only a diameter, but we want to list the diameters also in the list of chords. So I'm going to add to this segment LN and another chord just like that one that is also a diameter, which is segment VR. So we should have 6 chords in this picture. Next, we want to name the secant lines. Now, secant lines look almost like chords, but they will be lines that go all the way through the circle and touch in 2 places. So the first one here is line RS, and the other one is right here, and it's line LR. Okay, next we want our diameters. So just like we mentioned before, our diameters are segment LN and segment VR. And again, this is because their endpoints are on the circle and they are segments, but they also go through the center of the circle. Now, it's really important not to list the chords as diameters, but you do list the diameters as chords. Next, we have our tangent line, and we only have one tangent line in this diagram, and it's right there because it is outside the circle and barely touches the circle in only one place, and that is line TS. And remember, this is a line, not a segment. Next, I have the radius. Now, we have 4 radii in this picture because that's plural of radius, and they all connect the center with a point that's on the circle. So I like to start all my radii with the center of the circle. Now, this isn't necessary, but it helps to make me remember that one of the endpoints of a radius is the center of the circle. So here's my first one, segment MV, second I have segment MN, next I have segment ML, and last I have segment MR. Next is the center of my circle. Now, the center of my circle is right here in green, And that's just going to be point M. We don't have a symbol for that, we just write the letter M, and we're done. And last, the point of tangency. And the point of tangency is where your tangent line or lines meet the circle. So again, that's just a point, and in this case it will be S. Moving on to our last question here, we are going to bring in some coordinates, and we are going to name the coordinates of a bunch of different points that are on one or more of these circles. So first of all, when we name coordinates, we always have to remember that we're going to name them in this order, which is X, comma, Y. So we always move across left or right, then up or down. Okay, first they ask us for the center of circle C. The center of circle C is right here at the yellow dot, which is C. And C's coordinates are 4, 6. 4 to the right and 6 up from the origin. Now the center of circle D is going to be right here at point D, which is at 4, 4. Then we're asked to find the endpoints of a radius of circle C. Now here is a radius of circle C, and it has two endpoints. One is at the center of the circle, which is C, at coordinates 4, 6, and the other endpoint of that blue segment is A, which has coordinates 4, 8. Now I could name that one, but I could also name this other radius, which is right here of circle C. So I could also, or say C, 4, 6, and D, which is at 4, 4. So either pair is just fine. Next, I'm asked to find the endpoints of a diameter of circle D. Now remember, a diameter does connect 2 points that are on the circle, but it must go through the center of circle D, which is D. So this segment in green is the segment I'm looking for, and the endpoints of that segment are F, which has coordinates 0, 4, and B, which has coordinates 8, 4. Next, I'm asked to find the endpoints of a chord that is not a diameter. Now if I look in this picture, the only chord that I have that is not a diameter is this one, which is segment EB. Now it has endpoints E, which has coordinates 4, 0, and B, which has coordinates 8, 4. And the last thing I'm asked to do is to write the equation of the line tangent to both circles. Now, that line they're talking about is right up here. Now, if it's tangent to both circles, it just barely touches each circle in one point and is outside of both circles. So that line in light blue there is the line I'm looking for. Now, it is a horizontal line. It goes straight across, and it crosses the y-axis. So this is a y equals line. So we look at where it crosses the y-axis, which is right here, and that's at 8. So I write that equation of the line as y equals 8. This concludes the video on section 11.1, parts of a circle. Thanks for watching.